Okay, right. So let's come back to what we would like to look at today. And so there's a new topic, right, which is on sealed classes and interfaces. Okay, basically sealed types. Okay, a class can be sealed, an interface can be a sealed interface. Okay, and this is available from Java 16 onwards. Okay, yeah. Now I mentioned about two keywords which we have already seen. We have seen a keyword called final, and we have also seen a keyword called abstract. Yeah, what are the achievements of both of them? What do they achieve? It's more related to the inheritance hierarchy. And this is related to the inheritance hierarchy. So in the inheritance hierarchy, we have something like this. Yeah, we have the object class. Fine. So let's look at that from the class point of view. Okay. So you have an inheritance hierarchy. So there is some kind of a class here. Okay. C1. Okay. Fine. If this was declared to be final, in that case, yeah, what happens?
You cannot have a subclass.
Fine. You cannot create anything under this, right? Nothing below this. No subtype. Final is no subtype. Other was saying, okay, here is a class. Okay, and this says abstract. Okay, what would it mean? That means it's forcing you to have further subclasses, right? Unless unless you have further subclasses, fine, this won't be useful. It's designed for creating subclasses. One is saying stop subclassing, other is saying, okay. Now a third one was a normal class, right? It's neither abstract nor final. Okay, if it is not final, yeah. So one is final or a non-final, let's see. So if it is not final, then you can have subclasses. Fine. You can, it's up to you. Fine, you would like to have subclasses, you can have. Okay, now let's say if we designed our class called account. Okay, it may be abstract or even if it is not abstract, but it is not final. That means we can have subclasses. Okay, when we designed account class, we were knowing that for account class, there are only going to be 2 or 3, whatever the type of account we want to have, only those subclasses can be there. Fine, we can have current account, savings account, deposit account. Okay, let's say these are the types of accounts. Fine. Now you have designed account class and someone will come and say, okay, we designed it, so thinking in mind that yes, there will be only 3 subtypes of this, right? And then someone says, oh, let me create my some new kind of a account class. I want to have a subclass, and we can't stop that. We can't stop anyone from subclassing. If you want to stop, then you won't even have a subclass like savings account and the current account. We want to control the inheritance hierarchy. We want a strict inheritance hierarchy in a very fixed way. You have a pre-decided hierarchy. Oh, this type, I'm creating, each time you are defining a class, you are creating a new type, class or interface, right? It's a new type being defined. So this type will have only these subtypes, limited subtypes. Okay, so that can be done by using sealed classes or sealed interface also. Fine, it's about having subtypes. So when you have any type, right, maybe a class or an interface type, okay, you can declare it to be a sealed type. But one thing, whenever we say this is sealed, okay, so if we have a sealed class, okay, fine, for example, if I say sealed class, so if I'm defining sealed class, I'll say, okay, I have a sealed class account, okay. Then at this time itself, you are supposed to specify what are the subtypes it will have. So using the, fine, this is again a keyword, but it's a contextual keyword. Okay, this is a contextual keyword, sealed. Okay, so sealed class account, and then the syntax uses permits. So if it is a sealed class, you will have to specify permits. Sealed class or an interface, fine, it might be even an interface which is a sealed type, but with permits you specify the subtypes. Fine. So under account class, yes, what are the subclasses I would like to have? Or I only want to have current account. So it says, okay, I only permit current account, comma, savings account. Okay, and then yes, you have your definition. That's fine. The idea is this. So when you say sealed, okay, you will have a list of subtypes to be mentioned, and only those two classes can say, oh, they extend from account. No one else can create a class which extends from account. But one thing about the subtypes here, these subtypes, can they be just any type? See, what's happening is, yes, you are having a sealed subtype. Here is a sealed type. Okay, sorry. Okay, here is a sealed type. Okay, SC, sealed class, that's it. Okay, fine. Then what, so it says, oh, I have these two fixed subtypes only, right? This is my type 1, this is subtype 2. Okay, for a type which is a sealed type, yeah, what can be the subtypes?
No, you cannot. You cannot inherit from a sealed class.
Yeah, sealed class, it has said it permits these two, right? So this is C1 and C2, which were in the permits for sealed class. Okay, fine. So sealed class says it permits C1 and C2. What about the C1 and C2 having their own subtypes?
Cannot.
Fine. Oh, why not? It can. Fine. You want to have sealed subtypes? Yes, let it be. But then this should also be a sealed type. So you have a fixed hierarchy which is known. Direct subtype of my SC is SC1 and SC2. They are sealed. Okay, they can be sealed, or the subtypes of a sealed type can be either again a sealed type, so it controls the subtypes. The idea is to control subtyping. Okay, not just permit anything to be available. Okay, so a subtype of a sealed type will be either a sealed or final. You say sealed or final. Fine. Subtype of a sealed type will be sealed or final. You have a sealed interface. Yeah, subtype can be a sealed class or a final class. Fine, we can have a sealed class or a final class. Okay, fine. Just for so but sometimes people say no, no, no. We would like to have. So you might have an argument says, okay, no, no. I would like the direct subclasses are fine. You control the direct subtypes, but still, I would like to go for further subtyping. It's not encouraged to do that, but it allows you to do this by explicitly mentioning another contextual keyword called non-sealed. So we can have there are two things. You can have sealed as well as you can have a non-sealed. So non-sealed is used in a subtype of a sealed type. So subtype of a sealed type can be sealed again, final, or you mention non-sealed to allow like all other regular classes. Okay, it can then, so if you are saying this is a non-sealed type, okay, then it can have any kind of any number of subtypes. There's no, then nothing, no rules on that. Then you are not controlling. So by saying non-sealed, you are saying, okay, this, the subtypes of this are not controlled. Okay, so sealed is for controlling the subtype. Fine.
This is a security thing, sir.
Security, and also there are many things which are yeah, security in the sense not wrong usage of a type which you were creating a type for a particular purpose, right? Okay. And the subtypes, if you have defined the subtypes, right, along with it, okay,
Only they can enter it.
fine. So you don't want someone else to use it in a different manner. Fine, doing his own subtyping and using it in a different manner. So for that reason, yes, we have the sealed type. Okay,
Is
so
there something called non-sealed?
yes, non-sealed is there because sometimes just to permit someone to say, okay, you would like to have you have a sealed type at the top, fine, but a subtype of the sealed type which you have given may again say, no, I would like to allow, I don't want to control my subtyping. So a child says, no, so this is a sealed class, but this child here can say, okay, I allow, I don't want to limit the subtyping here. Okay, or so under this, yes, the one thing is you will say this is final, no subtyping, or like just like a case here, this one has subtypes which are sealed type. So sealed type will have a subtype which is a sealed type again. Okay, or a final type. Fine, this is good. That's the way you should control. But someone for some reason wants to have a subtype which is non-sealed. So this is saying, oh, this can be a non-sealed type. Okay, so you have to explicitly mention non-sealed. It's like the normal classes. Okay, fine. So but by doing this, the compiler is making you aware. You have this as a subtype of a sealed type, and you really want to allow subtyping which is not controlled. Okay, so you explicitly mention non-sealed, saying yes, I would like to have subtyping which is not controlled. Okay, so non-sealed is about subtyping a sealed type and making it, the subtyping below this is uncontrolled. Okay, so here sealed is about controlling the subtyping. Fine, clear on this? Okay, see, for example, from I'll explain with a small example where sealed are useful. Okay, they are more applicable to the what we know from nature. Okay, yeah, or there are many things which are, a fixed classification has been done, right? For example, yeah, everything is either a living or a non-living, right? So that's the first level of classification. You have things, okay, beings, and okay, so someone says, okay, we have a type called being, okay, and we have living beings and non-living, right? Okay, fine. Under living, okay, you have classifications, right, which are there. Okay, so fine, you have birds, mammals, and all those things, right? But that's a fixed list which is known, right? Someone comes up and says, no, no, let me add anything I like. No, that shouldn't be allowed, right? So you keep this as a sealed, again, this as a sealed, the subtypes here will be sealed. And the leaf thing, the final thing here will be final. So under this, somewhere you'll say this is final. There's no more subtyping. Okay. So there are things from the, which are fixed. Those classifications are available, right? So anything where a fixed kind of a classification is known and you want to create a hierarchy for the types for them, fine, create a type for each of them, and you want to maintain a hierarchy, fine, then go for the sealed types. Okay, see a sealed interface. Let me just give an example of a sealed interface. Since this is in Java 16, fine. Another thing which actually personally I would like to see happen in Java 6 from in Java here, which is related to the number subtypes. Fine. See, we have the abstract class called number, and under number we have the byte, short, integer, long, float, double. We even have, what are the other things we have? Big integer, big decimal, atomic int, atomic long. There's no control. Someone can come up with someone might have developed his own subclass of the number also, right? Okay, so we are not interested in controlling all that aspect. Fine. Many times a place where we feel that something like this should be you might need is where we have okay, we were trying to use some this is related to generics again. So when we have a bounded type parameter, yeah, for some class being defined, okay, so there is some class, okay, a bounded type parameter t, and you'll say, okay, this extends, and what? If you say number, then it's allowing everything. I'm only interested in those wrapper numbers. I'm interested in the numbers which are the wrapper classes, boxed types, not the big integer, big decimal, or anything else. Now, I don't have a type here, right? I don't have a type for this here. Can I give, can I have a super type which is exactly for the byte, short, integer, long, float, and double? One thing about all of these, byte, short, integer, long, float, and double, is they are all final. All our wrapper classes, even the big integer, big decimal, they are all final. Okay. Now see what can be done with this. Yeah. How do we solve this issue? Yeah, because I'm interested in putting here and say, oh, it's only the big integer, big decimal which should be allowed. Oh, there are two of them, right? Big integer, big decimal, the big types. We have the So if you look at the whole number hierarchy, fine, all the numeric types, okay, you can say, okay, I have the boxed types for covering all the wrapper classes. Oh, can I have something which says these are all the wrapper classes? So I can use it by using an interface. See, these are all unlinked. See, from classes point of view, you can't create a class hierarchy across. A class cannot have two superclasses, right? We know that. Number is a common superclass. Fine. But I'm interested in picking up a few things and say, let me create a type for this. Fine. Okay. See, now I'll give you a thing which is suggested, okay? That's more of a suggestive thing. Okay. So something like this can be there. So fine. So example for a sealed interface. Okay. Fine. So we could, for example, say, okay, let's have a sealed interface, boxed types. Okay. I'll say it permits. What does it permit? What are the box types? It permits.
Boxing and boxing.
No. Box type means a wrapper classes. It permits.
Oh, okay. Int long.
Instead of saying that, I'll say boxed number,
Okay.
comma, character, comma, boolean. Okay. Fine. And we understand one thing which is common across all the boxed types is they all implement the comparable. I mentioned that, right? All the wrapper classes implement comparable. So if someone is saying yes, so we can say it implements comparable of. Okay, so it's a interface box type of some, let's say box type of B, it implements comparable of B. Okay, fine. Since it implements comparable of B, yes, it is giving us the operation of compare to. Right? Fine. So a box type which has a compare to method. We have not mentioned, but it's coming because sorry, not implements. This is interface, so this will be extends. Okay, the keyword here will be extends. Okay, fine. The next thing can be, we have to also specify about the sealed interface. So we have another interface, sealed interface, boxed number. Character is a final class, boolean is a final class. Fine, so those are already there. They are final subtypes. One subtype remaining was boxed number. So we have the boxed number and it permits box number of B permits integral numbers, comma, floating numbers. Okay, fine. Okay, and then we have the sealed interface. So we have the two types, subtypes called integral number, and it will say it permits. Yeah, what does it permit? Byte, short, integer, and long.
Long.
Okay, and again we have the sealed interface.
Character.
Floating number permits, and what should it be? Byte, short, integer, long, float,
Double.
float, and double. See, now we have that hierarchy which is created using interfaces. Okay, where at the leaf, yes, we have those classes which are the byte, short, integer, but we got a hierarchy. You know, now what is the hierarchy we have got? We have got a hierarchy called boxed type, having a subtype called boxed number, having a subtype called integral number, and that has the byte,
Integer.
short,
Integer.
integer,
Long.
long, okay,
Floating.
floating number, and that has a float and double, and under boxed number, yeah, box number is done. And at that same level as the box number, we have the character, and we have the boolean. Okay, fine. Huh? String is not in this hierarchy. String is not a boxed type. So this is, you know, summing up all the wrapper classes. Someone wants to permit all the wrapper classes, or he can just say boxed type. Someone wants to permit all the numeric ones, he can just say boxed number. Or someone only the integral types, or this is what he can use. So we have created these new types. But what are those? Box type, box number, integral number, floating number. And so this is, you know, the hierarchy which we have brought in. Oh, the other things you can see, they are all final. These are all final. Byte, short, integer, long, float, double, the character and the boolean, oh, they are all final things. So there are no subtypes under them. But everything else, yes, we have. So we have been able to create 1, 2, 3, and 4. 4 types of our own. Fine with that. So we have done our cherry picking of the final classes which we have got, and we would like them to be called as a particular type. Okay, so it allows you, sealed interface, it will allow you to cherry pick classes, final classes only, fine, and make a type out of it, a common type for them. Fine. So of course, one more thing what could be done here is, actually there are these so, and I'm saying boxed number, okay, it's an interface I'm saying, right? So this could have been having the set of methods which are there in the number class. It can have those abstract methods. Okay, so box number should actually be including the abstract methods, and the number class can then say, okay, I'm implementing the box number. Okay, or maybe there is a separate interface and this extends that interface. Okay, so for example, yes, see, this is managing by whatever is already there in the Java class hierarchy, whatever we have seen, right? We are managing from that itself, right? So yeah, so for example, what could have been done here is, yes, when we said permits this and this, we could have said it extends number interface. Okay, where, fine, when I'm saying number interface, I would like to see a interface. So there's a public interface called number interface, and that has there are 6 methods in the number class. So those 6 abstract methods which are there, fine, public method returns a byte, method called byte value. Okay, fine. Yeah, I think there are 6 methods. Yeah, byte. So we have the method called to return short, int, long, float, double. Yeah. Okay, and the number class also implements the number interface. The class which is number, or that could be implementing the number interface. So if that is done, yes, fine. There's no effect to the existing code. It's fully backward compatible. If these changes are added, yeah, it becomes fully, still it remains compatible, but you get those types. Okay, you get the luxury of getting these kind of types. Okay, then this additional things, box type, yes, a box number or a integral number or simply a floating number, right? Okay, and so someone says, okay, that bound is saying, oh, it's an integral number. You will still be getting the methods of, in the box number we are saying, oh, it is extending from, box number extends from number interface. Fine, box number is a number interface. So methods, those 6 methods of number, they were available in all of them, right? They're available in all of these subtypes. Yeah, so that becomes available. See, for a bound, in generics, when we specify a bounded type, those methods of that type become available. So it's not only about adding the type, but also getting the appropriate methods available for them. Okay, fine. That's why this box type was saying, oh, it is extending from comparable. Okay, fine. So clear about the idea of a sealed type, right? Subtype of a sealed type has to be mentioned when you are defining the sealed type by using permits. Right? So permits is another contextual keyword. Okay, so yes, we came across contextual keywords. Fine, we have those reserved keywords and the contextual keywords. So here are the contextual keywords which we have come across. So Java has reserved keyword, contextual keywords.
And what is another contextual keyword?
Sealed, non-sealed, right?
Okay.
Fine. And earlier there was one called yield, which we had seen in the switch case.
Yield, E-A-L-E-D.
Y-I-E-L-D, yield.
Y-I-H.
Okay. And so,
Okay.
yeah, any questions? Yeah.
No, sir.
Okay. Fine, then we'll continue tomorrow. Okay.
Good night, everyone. Good night, sir.